Draw a circle of radius 1, centered at the origin, the unit circle. Now take any angle theta, measured from the positive x-axis, and mark the point P where its arm meets the circle. Here is the definition that powers all of trigonometry. The x-coordinate of P is cosine theta, and the y-coordinate is sine theta. That's the leap. Cosine and sine are no longer trapped inside a right triangle. They're simply the coordinates of a point going round a circle. And because the point can go all the way round and round again, the angle can be anything at all. Past 90 degrees, past 360, even negative. A handful of angles come up constantly, and their values are exact, not decimals, worth committing to memory. At 0, cosine is 1 and sine is 0. At 90 degrees, it's the reverse. Cosine 0, sine 1. In between sit the famous 3. 30, 45, and 60 degrees. 30 degrees gives cosine root 3 over 2 and sine 1/2. 60 degrees swaps them. Cosine 1/2, sine root 3 over 2. And 45, the symmetric one, has cosine and sine equal, both root 2 over 2. Notice the pattern. As the angle grows, cosine slides down from 1 while sine climbs up from 0. They're a mirror pair. Because cosine and sine are coordinates, their signs just follow the signs of x and y in each quadrant. In the first quadrant, both are positive, so everything is positive. In the second, x is negative, but y is positive, so only sine stays positive. In the third quadrant, both coordinates are negative, so sine and cosine are both negative, but their ratio, tangent, is positive. And in the fourth, x is positive again, so cosine is positive. That gives the four-quadrant pattern all sine tangent, cosine, a cycle worth knowing cold. Now the payoff this whole topic builds to. Keep your eye on the green dot's height, the sine of the angle, as the point travels around the circle. I'm going to carry that height across to the right and plot it against the angle. As the angle sweeps round, the height rises to 1 at the top, falls back through 0, dips to -1 at the bottom, and returns. And the trail it draws on the right is the sine wave. The circle didn't just relate to the wave. Unrolled along the angle, the circle is the wave. Every wiggle of sine is the shadow of a point going round. Let's find cosine of 150 degrees. Exactly. First, locate it. 150 is in the second quadrant, where cosine is negative, so we already know our answer will carry a minus sign. Next, the reference angle. How far it is from the horizontal axis, which is 180 minus 150, 30 degrees. Cosine of that reference angle, 30 degrees, is root 3 over 2. Attach the negative sign from the second quadrant, and cosine of 150 is minus root 3 over 2. Reference angle for the value, quadrant for the sign. That's the whole method for any angle. 3 traps. 1. Don't swap cosine and sine. Cosine is always the x-coordinate, sine the y. Say x first, then y. 2. Get the size from the reference angle, but always get the sine from the quadrant. Forgetting the quadrant sign is the number 1 error here. And 3. When an exact value is asked for, keep it exact. Leave the roots as roots. Don't collapse to a rounded decimal. Master those and the unit circle turns any angle into a quick, exact answer. So on the unit circle, cosine is just the x-coordinate, and sine is the y-coordinate, which extends them to every angle, gives you the signs in each quadrant, and, unrolled, becomes the sine wave itself. Lock in those exact values, and this becomes second nature. Next, we graph these functions properly. For more, that's MarkScheme.app.